Hey, welcome back. So I've been having a lot of fun with Rust recently, as you know, and one of the things that's been in my mind is which web server framework should I actually be using? Now, it seems to be in the Rust landscape there are two frameworks. One is the Actix Web Framework, and then the other one is Rocket. And both of those frameworks have got their pros and cons. But in this video, I thought I would look at it from a performance perspective. And the reason I'm going to look at it from a performance perspective is Actix Web is one of those web server frameworks that has been absolutely dominating in the techempower web server rankings. And then Rocket has been getting, well, what's the best way of saying this? It's been getting a little bit of criticism for being slow. Now, the real question in my mind is how fast can Actix Web go? And how slow is Rocket actually? And because I think from my perspective, if there's a massive performance difference, then I'm probably going to be looking at it and going, hey, you know what? Performance is going to be a massive issue, and therefore I'm going to use that as an influencer. But if there's not a huge difference between the frameworks, or if the performance is good enough, then we can get down and look at sort of frameworks and features, and I can just sort of put that aspect out of my mind. So that's what we're going to do in this video. From scratch, we're going to code up Actix Web, and we're going to code up Rocket, and then we're going to run a quick performance test, and then we're going to see how the two compare. So at the end of this video, you should have a good idea of the performance differences between the two frameworks, and then you can make your own choices on whether web performance should be a factor in your own decision making. All right, so the first thing that we're going to do is we're going to code ourselves up an Actix Web Server, and then we'll code ourselves up a Rocket Web Server. So to do that, all I'm going to do on my terminal is I'm just going to type in cargo new, and I'm going to call this Actix Web perf. Okay, so that's going to very, very quickly scaffold me up a new project for Actix Web. So as you can see, that's now created. So we'll just cd into that, and we will open up Visual Studio Code. So we've got a scaffolded project just now, and what we'll do is, I think what we'll do is just copy and paste things in from the website. So this is kind of how you would do it if you were doing locally. So I'm going to just bring up my Brave browser for a second, and we'll bring up the Actix website, which is at actix.rs. So we'll just open that up. So as you see, it's a powerful, pragmatic, and extremely fast web framework for Rust, and it really is, and it really is blazingly fast. It says that Actix is blazingly fast. Don't take our word for it, see for yourself. Okay, we will see for yourself. So to kind of, basically what I'm going to do is I'm going to take this example here, I'm going to mod it a little bit. So I'm just going to copy and paste it in, and then we're going to mod it a little bit, and I'll talk through what it actually does. So we'll just do a Control-C there, and then we'll go back into Visual Studio Code, and then we'll open up the source main RS. So as you can see, at the moment, it's got a very simple hello world. In fact, if I just go into my terminal for a second and typed in cargo run, you'll see that will compile for a second, then it'll come back with that hello world. So I've got a working application, but let's come back to VS Code again. And what we're going to do is just paste in that piece of code that we had there. Now, the first thing that you can see there is there's a couple of swigglies coming in, which is we've got an unresolved import for Actix Web. So to be kind of lazy about it, all I'm just going to do is open up my cargo toml file, and I'm just going to add that as a dependency. So I'll just type in Actix Web, and I'm going to take version 3. We'll just save that. And then if we come back into our main for a second, let's just do a cargo run on that again. It's going to fail, obviously, but then it'll have done the various compilations. So you can see I've got that dependency. It's going to download, compile everything. And then we should have a very, very quick setup happen. Okay, so you see that's running now, it's all compiled, but let's just make a couple of changes in VS Code so we can get it in the state that we want. So I'll bring back up Visual Studio Code. Okay, so the first thing I'm going to do is I'm going to simplify things out a little bit here and talk through actually what the code does here. So in this case, we've got this sort of function called greet, which is basically, as you can probably kind of guess, you pass in a name, and then it's going to get the name and do a bit of formatting, and then it's going to say hello your name. Now, in order to standardize this when we do the rocket test, I want this to be a basic hello world. So I'm going to simplify it out a little bit. I'm just going to use the format macro for a second, and we're going to type in hello world, and then that allows us to be sort of nice and consistent. And then I'm going to change this to be hello. I don't need that rec.http request because I'm not sort of pushing anything in from there. So, and then I can basically remove that from here as well, and that gives me a sort of simplified handler, which is just going to return hello world, and and it's going to implement this kind of responder trait that's part of Actix Web. So I've got my simplified handler that's going to say hello world. Now the next thing that I need to do is just go and modify this main function a little bit. So, you know, to make things a little bit tidier, I'm just going to print something up there. So I'm going to print that it started. So we'll use the print line macro here, and we'll just say server started on 0.0.0 port 80. Okay. So that'll give us a nice little pointer so that we know that the thing's actually up and running. So a little prompt there. I don't need, the next thing is gonna spin me up a brand new HTTP server, which is cool. I don't need this greet route anymore because I've simplified my code there. So what I'm now gonna do is I just need a route off of the kind of the main route. And I want it to call my hello handler there. So as you see there, it's the / root is going to get mapped to a get request, and then that's going to get forwarded on to greet. Now greet we've just removed, so I want this to go to the hello handler, which I just created over here, and that will create me my hello world. Now I'm going to move this from 127.0.0.1 to 0.0.0. So the reason I'm going to do that is if I want to do something with Docker later on, then it's going to be able to sort of respect that as well. So there we go. I'm just going to save that. That's kind of cool, and literally that's all I need to do to get Actix Web up and running. So now if I were to run cargo run again, it'll take a couple of seconds, and you'll see server started on 0.0.0 port 80, and now I could just curl this and I will get a response. So if I curl localhost 8080, and you see it comes back with hello world. So I've got my Actix web server up and running. Now I said I wanted to do a performance test against that. So what I am going to do in this particular case is I'm going to use a tool called WRK. It's kind of like Apache Beam, but it's a little bit more stable, especially on Macs, etc. So what I'm going to do in this test is I'm going to use 8 threads, and I'm going to use 256 simultaneous connections as the settings, and I'm going to run the test for 30 seconds, and then it's going to hit localhost 8080. So all that's going to happen on this is this little tool is going to spin up these 8 threads. It's going to have 256 simultaneous connections, and then it's just going to basically hit that root node a shed load of times, right? And then it's going to tell us basically how many requests per second it was managed to run it. So let's just hit that. This is going to run for 30 seconds. And then by the magic of YouTube, we'll see the result in a second. Alrighty, so the test is run, and you can kind of see there that it's pretty fast. I mean, just have a look at that for a second. That's 109,000 requests per second, right? And that's me running using cargo run, right? So I've not even done a release build in this case. That is insane performance. All right, so the next kind of clue, as you can probably guess, is, well, if this is what I'm getting from just using cargo run and using a debug build, how is that going to perform if I were to run this as a release build? So let's find out. So I'm just going to Control-C from that, and then what we will do is type in cargo build, and we'll do -- release, and then we'll let that compile. Alrighty, so that's compiled now. So what I'm going to do is just go to my target folder and look at the release. And then execute the binary that we just created. So it should be called Actix Web perf. So we'll just run that, and you see server started on port 80. And then all I'm going to do is very quickly just curl that again so we can see that's working. And now that we know our web server is up and running, let's run the exact same test as we ran before. But of course, now that we're running from a compiled release build exe. Alrighty, so the test is completed, and I want you to have a look at this number, right? It's absolutely insane. 274,849 requests per second. That is insane performance, absolutely insane performance. And again, you would sort of expect that, right? Because if I bring up techempower, let's bring up the techempower benchmarks, and if we round 20 was the most recent one. But again, if we were to look at Actix Web for a second, so let's just find the plain text test, and then if we just scroll down a little bit, where's Actix? Let's just do a search. There we go. So as you can see there's Actix, and it's running at sort of 7 million requests per second, you know, on that sort of test hardware. So, you know, it's 10th in the list, right? So it is an insanely fast framework. So, and you can kind of see that from our machine there. Now, probably the other thing we'll do before we go and look at Rocket is let's actually just see how this looks on Docker as well, because quite often you're going to be running with containers. So let's just create ourselves a very quick Docker ignore file for a second. And then I'm going to be super lazy as well. What we're going to do is I'm going to create a Docker file, but rather than have you sit and watch me type out a Docker file, I am just going to use one that I've sort of pre-built here. So as you can see, I've got kind of Rust is going to be my main builder image. I'm going to do a multi-stage build on this to be super quick. And all I'm going to do is use the sort of out-of-the-box Rust official Docker image as my builder image. I'm going to copy everything in this Actix Web Performance folder into my app folder on my Docker image. I'm going to set that as the app directory, and then I'm going to run this sort of cargo build release. Okay, so that's really all I'm going to do there. And then I'm going to use for my actual running image, I'm going to use a Debian Buster Slim image, which is a smaller image than the Rust builder image. I don't need all of the Rust compiler tools, etc. And that's like a sort of 60 meg image, so it's pretty good. And then what we're going to do is we're going to copy everything from my release folder. So if we have a look in here, you see target release, and I called it Actix Web Perf. So if I just call this here Actix Web Perf, so I'm going to copy the binary that we create from the compile, and then we will just put it into this folder here. And then all I need to do is start that is just call my server here. So we'll call the web server. So that's my Docker file. All right, so what we're going to do now is just build our Docker image for a second. So to do that, as you can see, I've got my Docker file in my folder here. So I just need to run docker build. We'll give it a tag of Chris Hay UK /Actix perf. And then we'll build whatever's in this folder here. So we'll just run that for a second. That's going to take a few seconds to build that, and then I should have my image. All right, so my Docker image is built now, so all I need to do is just run that very quickly. Again, if you look at my, just before we do that, if we have a look at my screen a second, you can see I've just created that. I've got a 72 meg image, so it's a pretty small image. It's not a large image there, and that's because I use that Debian Buster Slim image on my builder. So let's just clear the screen, and now what we're going to do is just run that locally on my machine. So if I do docker run --init, the reason I'm using --init is so I can do a Control-C and send the kill signal to my container whenever I want. Without that, it just sort of gets stuck, and I have to do a kill it using docps, etc. So it's a nice little tip there. I need to do a port mapping, so obviously I'm exposing my ports in 8080 in the container, and therefore I want it to be 8080 outside of the container as well. So that's what that -p there is doing. And then I'm just going to run Chris Hay UK Actix perf. So if we just run that for a second, and you see my server started on port 80, and if I, on this one here, just do the curl localhost 80, you can see my hello world is running again. And if we run the same test as we run before, another 30 seconds, 8 threads, 256 concurrent connections, and then in about 30 seconds time, we'll know how many requests per second it runs with a Docker image. Alrighty, so the test is run, and as you see, it's running at around 41,000 requests per second. So it's quite a hit, right? Running Docker on your machine, there's quite a performance hit that sort of happens. The difference between running natively and running your container. You know, I was running at what, 270,000 requests per second before, but now that I'm running that server within a container, it's only running at sort of 41,000 requests per second. So I've taken a fairly major hit by running my container here. I've lost something like 6 times performance. But again, this is super fast. Again, you'll get different results, and you're not going to run your container on your local machine. That's where you're going to take it to something like Google Cloud Run or you know, Amazon EKS or something like that to run that image. So we'll probably do that, is take the container in another video, is take the containers that we built here and run it on one of the clouds and see how that actually performs out in the wild in production, not on my machine. All right, so we've got a baseline. So we're running at roughly 270,000 requests per second natively, and we're running about 41,000 requests per second within a container. So let's now move across to Rocket, and then we can compare performance baselines. And then they say Rocket is a really nice framework, but a lot of people complain and say that it runs very, very slow. So let's find out what's happening there and see if we can do something cool. So now what we're going to do is do exactly what we did with Actix, but this time do it with Rocket. So first thing we're going to do is we'll just scaffold up a new application. So cargo new, and we'll call this Rocket Web Perf. So that will just scaffold me up a nice new application. So we'll cd into that. We'll do a cargo run just to make sure that it all works. You see it comes back with hello world, and then we'll do a code dot, and then we can have a look at our code. Alrighty, so there is our hello world application. So the next thing that we are going to do here is we're going to go back into Brave, and we will bring up rocket.rs. So there we go. Meet Rocket. Rocket is a web framework for us that makes it simple to write fast, secure web application without sacrificing flexibility, usability, or type safety. Yeah, very cool. Type safe, boilerplate free, easy to use, extensible. So a lot of people really like this framework, which is cool. So what we are now going to do is follow the example. So let's click on the get started here. And then there's a quick start, so we'll look at that. Okay, so we need to add Rocket as a dependency. Let me just copy this. That's fine. We'll come back into our Visual Studio Code. Let's go to our cargo toml, and we'll add that as a dependency here, and we'll save that. Cool. And now let's come back into main. And then here we go. Here is our hello world. That's pretty good. Macro use, extern create, blah, blah, blah. So let's just copy that, and then we'll bring up Visual Studio Code again. We'll get rid of this. Okay, so good news is that's exactly set up the way that we want it. You can see that they're using a macro use rather than the sort of the more recent use statement that comes with Rust, and they kind of, you know, if you look at the Rocket website, they kind of prefer that. So I'm not going to worry about that too much. We're just going to leave that here because I want this to be close enough to an exact test. You can kind of see it's using this sort of decorator type syntax here to say this is a get, and you're going to route to anything on /. So same sort of thing. If we hit localhost 00, it's gonna go to that. That's fine. It's going to return hello world, which is going to use a string literal here, and then you can see that's been returned here with my string declaration as my return type. So that's all good, and it's on index. And then if we look at the main kind of Rocket file here, Really nice way of setting this up is basically you're calling build, where it's going to build your code there, and then it's going to do some mounting. So it's going to mount that to /, and then it's going to go and figure out whatever your routes are and then map that. So in this case, it's going to put the word, it's going to use the index handler that we've set up over here, and then we're kind of good to go. Again, really nice syntax. It's really not got a lot of boilerplate. It's actually very quick to code against. It's a really nice sort of format. So I kind of like this server very, very much. Now, the last thing I want to do though is I just want to override a couple of the settings here for a second, because I want to use port 8080 just for a bit of consistency, etc. So to do that, I need to create this thing here called rocket.toml, which allows me to basically put some configuration within here. So as you can see, I'm setting the address to 0000 like I did, so we can get it working on Docker a little bit later. And you can see I'm using port 8080. And we will do the exact same test as we did before. So I'm just going to do a cargo, actually, let's just clear that. I'm going to do a cargo run, and then it's going to take a second to just build up the web server that we just created. And once that's built, we will it should run, and then we'll just do a quick curl test, make sure it's working okay, and then we'll run the performance test like we did before. Alrighty, okay, so Rocket has started up. It's got a lot of stuff going on there. In fact, it's quite a noisy little thing. It's got the address, the number of workers, etc. So it's telling you a lot. But I guess that's useful for kind of debug purposes, right? So let's run a curl for a second. Okay, so it runs my hello world fine. And again, noisy little thing. It's coming back and it said it's matched the get and outcome and responses succeeded. So I know I am gonna have a bad performance test, right? Because there's gonna be a bottleneck, and the bottleneck is gonna be that it is gonna send all of this nonsense to the console as soon as I run this test. So I know I am going to get a terrible test out of this. Okay, so let's run that for a second. So it's the same test as before. And as you can kind of see, 8 threads, 256 connections for 30 seconds, and then we'll get an idea of how many requests per second. Alrighty, so it's finished its test, and as you can see, and as I predicted, it has only done 15,000 requests per second. So at this point you'll be going, oh, I said Rocket was slow, etc. And it's not. It's because look at what it's done there. It's noisy, and there's no point being threaded if what you're going to do is send all of this nonsense to the screen, all of this debug info, right? Of course it's going to slow it down, because it becomes the blocking point, right? It's the point of sync where there's only one console, and it doesn't matter how many threads you have. Whenever you're going to write to the screen, everything's going to have to wait for that. So that's what's happening here. So what are we going to have to do? Well, let's do a release build in the same way as we did before. So if we do a cargo build -- release, just like we did with Actix Web, let's build that out, and then hopefully the release build that is created should have better settings for release mode rather than debug mode, and then not be logging all of everything to the screen. Now, of course, I know it's going to do that, so it's going to be less noisy, and then we're going to expect better performance. Okay, so now it's built. We'll just get that started up there for a second. So I'm just going to go to my target, and then we'll just go to release, and then I think we called this Rocket something or other, so Rocket Web Perf. We'll just run that for a second. It's got a lot of stuff here, but you can kind of see there the log level has changed from critical. Yay! So that should mean that it should be filling up that screen when we run that test now. Same thing if I just run a curl localhost 8080. We should see hello world, which we do. Let's clear the screen. And now if we run our performance test against that, we should get a better result. So again, same settings as before, 8 threads, 256 simultaneous connections, hitting localhost 8080 for 30 seconds. And then let's see how this compares. And we are done. And you can see there, it's not bad. It's certainly a lot faster than it was before, right? And you can see that there's nothing coming through onto the console, so that's no longer the blocking point. And I'm running at a pretty respectable performance. That's 166,648 requests per second. Now, don't get me wrong, that is nowhere near as fast as Actix Web, right? Actix Web is running maybe not far off 2 times. It's maybe sort of 1.5 times the performance. It's running at 270,000 requests per second. And again, remember, you're going to get varying results. I'm just doing hello world, right? When you start doing things like JSON serialization and making database connections, then these results are going to be different. But using a plain text test gives you a bit of an idea of kind of the raw performance anyway. But 166,000 is a good result. I wouldn't be complaining about that too much. In fact, I mean, just to sort of prove a point, if let's come out of this for a second. Actually, let me open up a new tab. And if we go to, let's go to Chris source working, and we'll go to web server performance. If we take something like the Express, so node.js Express server, I just want to do this as a bit of a comparison. So if we go to Express performance, and then if I just do a node server.js, that's running at localhost 8080. If we do a curl localhost 8080 on that, and then, so you see that's working, the exact same test. Now, if I run that for 30 seconds, what you are going to see is the performance for Express is terrible. As you can see with Express, Express is running at sort of 21,000 requests per second, or 21,500 requests per second. So just keep this in mind, that the performance of Rocket, all right, it's not as fast as Actix Web, but it's 166,000. It's pretty darn respectable. I mean, even, you know, if I compare this to Express, as I said, it's still sort of, yeah, nearly sort of, what, 7 times the performance or something like that. So it's a lot faster in that sense. So just keep that in mind. It doesn't mean Rocket is slow. It just means that it's not as fast as Actix Web, but it is still a blindingly fast web server. Make no doubts about that. Now, for anyone that's going, oh yeah, well, everybody knows Express is slow. Well, actually, if you were to run something like Fastify, which is like considered as one of the faster kind of Node.js based services, that even then in that test it runs 80,000 requests per second. In fact, I'll do a video on comparing web server performances at some point as well. But even then, so Rocket still runs double the speed of Fastify. Obviously in JavaScript there is just.js, but that's not really, that's more of a kind of performance tune thing, and it's kind of in build at the moment, so it's not really a kind of main framework. It's more of a kind of sort of performance tune type thing. But either way, most people use Fastify or Express in a kind of JavaScript world, and even, you know, Rocket is just kicking it, right? I mean, Actix Web is insane compared to this, right? The Actix Web is 260,000 versus 21,000, but Rocket is absolutely going super fast. So just keep that kind of in mind. Now, the next thing that I'm going to do is let's go back to Rocket for a second. And we'll run the Docker test as well. I'm going to be super lazy in this one. What we're going to do is just copy everything in from the Actix Web one for a second. So let me just bring the 2 Visual Studio Codes for a second. I'm going to grab the Docker file that I created here. We'll just copy that in. Everything will remain the same. The only difference is we're going to call this Rocket and Rocket and Rocket. Okay, so we've got our Docker file, and then I am just going to copy also in the Docker ignore file as well, and then we are good. So let's close this out here. So I guess I made a mistake there. I forgot to copy in my Rocket TOML file that I created earlier. So in my Docker file, so all I really need to do here is, let me just grab this for a second, and I just need to put another copy in here. And what we are going to do is copy in the Rocket TOML file from here. .toml, and we will call that rocket.toml. Also, I could have put a dot in there, but hey ho, it's fine. Let's save that again, and then we'll just need to build that very, very quickly. That is now rebuilt, and now if we run our Docker file, you can now see it is running against 8080. And again, if I now come back to my shell, and this time if I run curl localhost 8080, we get my hello world. So we are good. So I'm just going to run my performance test again. Now, if you remember the last time with Actix Web, we were running at around 41,000 requests per second in a container. So let's see how this performs in a container test there. And again, as I said, in a future video, what we'll probably do is run both containers on something like Google Cloud Run and just see how it behaves in a cloud environment as well. But as I say, let's run this and then we'll see what the main difference is. Alrighty, so we have ran there, and as you can see, it's come back with 35,500 requests per second. So in a containerized world, you can see there's not a massive difference, right? There was a huge difference running on my machine, right? Between the two frameworks. One was run at 160,000 requests per second, the other was run at 270,000 requests per second. But when we bring it down into running within containers, you know, actually one is running at 35,500, the other one's running at sort of 41,500. So, I mean, Actix Web is still massively faster. Let's make no doubt about that. But honestly, I think the thing you should be looking at here and thinking about is performance probably shouldn't be your first concern, right? Yes, you will be able to get more performance out of Actix Web than you are going to get out of Rocket. Maybe that'll change in the future, maybe it won't. But as it stands today, Actix Web is faster than Rocket. But you know what? Rocket is still a pretty darn fast web server. So when it comes down to it, you know, when you're choosing a framework, go take the framework that makes most sense for you, right? And there's lots of good reasons to pick Rocket over Actix Web, and there's lots of good reasons to pick Actix Web over Rocket. So pick the thing that you feel most comfortable in, the framework that you feel more allegiance to, the framework that you prefer and enjoy writing coding in. And if you're in an enterprise world, you may pick the framework that has more enterprise level ready support. Again, that's your kind of choices. But performance wise, I just doubt that you're going to be in a scenario where the difference between running Rocket and running Actix Web is really going to be your killer decision point, right? So as you see, Rocket is not slow and Actix Web is blindingly fast, but they are both fast web server frameworks. Anyway, I hope this has been useful, and I hope you have a lot of fun and you understand how to run some performance tests for yourself and how to get started with Actix and how to get started with Rocket, and I hope you learned a lot from that. Anyway, hope it's been useful to you, and speak to you next time.